So in today's startups, founders need to know about something called the minimum viable product, or sometimes called the MVP. In startups today, instead of building the complete finished product, we're actually going to get out of the building and test pieces of the product incrementally and iteratively. And the question is, what are you going to test? Why are you going to test it? And how do you know what time to test it at? The idea is at the very beginning of the company, you're trying to answer two very general questions. One is the problem I think customers have, or the need they have, actually shared by anybody other than me? That is, while I believe this, can I find other people who have this problem or need? And the way you elicit some of those responses might be something as simple as a website that says, do you have this problem? Click here. Or in fact, you could just simply say, on a one-on-one interview, I'm trying to understand whether people share this problem. The next step is trying to understand whether the class of solution you're building, not the specific product, but whether the thing you're building in general solves the problem you've now kind of validated. Is, gee, what if we had a website that did X? Would that be exciting or interesting to you, or interesting enough that you would use it or pay for it? Or what if we had a physical device that did X or Y? When you're trying to test the solution, some mock-ups, wireframes, clay prototypes of just a general idea sometimes really elicits feedback a lot quicker and better than just having a set of verbal descriptions. So one of the hardest problems that entrepreneurs encounter, particularly those who are technical, is getting over the feeling that the MVP has to be bug-free and complete. Actually, it's the antithesis of this. You're not building a product. You're actually trying to elicit responses from customers. And while somebody might say, well, I need another week to finish the code, the real question is could we do a cheap hack with a PowerPoint slide? Or could we do something else to just figure out whether somebody would give us some answers? It might be that it comes down to you do need some functionality that really requires code, but the first set of questions you want to ask yourself is there some way to get here by not having to do all the engineering? Because that probably might be wrong at this point in time. It's not till we have something repeatable where people are saying, yes, will you just finish this feature set out and we'll buy it, then you actually want to start committing to real serious development. The other key idea is you got to remember is what you're doing with these MVPs are using them to run experiments. It's not that you're just throwing them out. When you go out of the building with an MVP, you have a series of hypotheses you're testing, and we happen to make you write down what do you expect to happen in this experiment. Not just go out and find out what happens, but what do you think is going to happen? Oh, Steve, I think if I show people, this feature, 45% of them are going to raise their hand and give me a check. Great. Now let's go out and test it. Well, what happened? No one liked it. Well, you know what? That wasn't a failure. That actually saved you from 6 months of development. So what we're actually going to do is actually enumerate what those key characteristics of this test will be, take that data and use it to modify our hypotheses. Some of the biggest mistakes entrepreneurs make in creating MVPs is thinking that they have any connection with a finished product. It would be nice if the MVPs were dragging you towards incremental completion of the product, but taking left and right turns cheaply and inexpensively is equally good. So again, the biggest trap is falling into gee, I have to write the code, or it has to match what our key architectural features are going to be later on. What you're trying to do is maximize learning. One of the good examples that come to mind for me about an MVP was we had a team, this robotic lawnmower that actually turned into a precision agricultural device, is one of the key things they needed to prove to me and themselves. Was one of their key hypotheses was whether they could tell the difference between a weed and a plant. And they said, Steve, we got it. It works great on the bench. And look at all our science and technology. And I said, well, that really doesn't matter. How's it going to work out in a dirty, dusty, noisy agricultural field? And they went, well, maybe a year from now we'll build a prototype and we'll get it out there. And I said, no. You need to do this in the class. Well, we can't build the robot. I said, no. I don't care. Why don't you put all the machine vision equipment on a cart you actually pull through the field and see if at least the machine vision equipment looking at dirt in an agricultural row can tell the difference in a live field rather than some simulated environment. And lo and behold, they worked their parts of their body off and actually figured out how to do that within a couple of weeks. And they were dragging a prototype of the robot that was actually trying to look for weeds versus plants. And they discovered, lo and behold, holy cow, we could do this. It cut probably a year off of their development cycle in giving them, and later on after the class, potential investors confidence that their technology would actually work.